Welcome back. Now we are going to discuss exercise 6.8. Again, the problems are very simple, but draw the figure every time. Okay. The first problem is a cylindrical hole of diameter 30 cm is bored through a cubical wooden block with the side 1 meter as shown in figure. The figure they are shown one cube . One cube is there and a cylindrical hole. Now one thing is there, you have to imagine in front of your eyes how the figure is, how the actually that solid is. One cylindrical cube is there of 1 meter side and you have to find a volume of it. Now if you want to find a volume of this cube is very simple. That is one cube, that is 1 meter cube. But now they have cut off some part of this cube. They are not cut off from the edge or from any side. What they are done? They are drilled a hole inside it, through hole. So here is a through hole. Okay, you know when the through hole is there, that much material is removed. So a cylindrical hole of 30 centimeters is bored. 30 centimeters is 0.3 meters. So the diameter, a cylindrical hole of diameter 30 centimeters means 15 centimeter is radius or 0.15 is the radius. And what will be the height? This through hole is nothing but in the shape of cylinder, right cylindrical shape. So what is the height of this cylinder? Is 1 meter because the side is 1 meter as the hole is through. So this is 1 meter. The diameter is 0.15 meter. So now what you have to do? This much material is removed. So first you have to, if you find a new block volume, I say the volume of new block is equal to volume of the total cube minus volume of the cylinder. So we have the total volume of this figure, this shape will be the volume of cube initially, and then remove the volume of this cylindrical shape hole. Now in this case, either you convert this to meter or you convert this to centimeter. If any which way you want, either you can say this is a 15 centimeter into this 1 meter, that means the 100 centimeter. So either you convert this meter into centimeter or you convert this centimeter into meter. As far as possible, don't go into the fractions if not that required. So here you can convert this into the centimeters. So this square is 100 centimeter and this is 15 centimeter. So what is the volume of cube? Is 100 cube. And what is the volume of cylinder? Pi r square h, that is pi r is 15 centimeter, pi r square, and height is again 100 centimeter. So just calculate this and you will find out the volume of this figure. Pause your video and do it now. Answer is 929,350 centimeter cube. In the second example, a toy is a combination of a cylinder. Now I told you every time they may not give you the figure. Now in this case the figure is given in the book, but in the exam it can be only word problem. They will describe the figure in words, but you have to draw the figure. Now let us see what they say. A toy is a combination of a cylinder, hemisphere and a cone, each with radius 10 centimeter as shown in the figure. Now figure here they have shown. So the figure is something like this. Cylinder is there, then cone on the top, and a hemisphere on the bottom. The figure is something like this. The height of conical part is 10 centimeters. That means this is 10. They are already given the cylinder, hemisphere and cone have the radius 10. That means this is 10 and this radius is also 10. Further they say that the total height is 60 centimeters. The total height means from this end to this end is 60 centimeters. But you know the radius, that means this is 10 and this is 10 they are given. So what will be the height of the cylinder only is 40. Correct? So you have to interpret the figure in this way. Only then you will be able to solve the problems. So whether the figure is given or not. Now in that figure they are given only 60. But these 3 dimensions you have to calculate by yourself. Okay. Find the total surface area of the toy. Now the total surface area of the toy, will be, how much it will be? The surface area of the cone plus surface area of the cylinder plus surface area of hemisphere. Okay, curved surface area. Now this will be curved surface areas. Okay, so this will be curved surface area of cone plus curved surface area of cylinder plus curved surface area of hemisphere. Correct? Very simple. You know all the formulas. Cone, curved surface area, you know how to find out. Cylinder, curved surface area, you know how to find out. And hemisphere, curved surface area, you know how to find out. Just substitute these dimensions in the figure and calculate the total surface area of this toy. Please pause your video here and solve this question. Now in this case, for the cone, first you have to find out the slant height. Otherwise you will not get the curved surface area. Correct? So you have to first either you start doing calculations here, or you do area of or you can just write that case 1 cone, then find out the L first and then find out the curved surface area of cone. Then second, cylinder. So you find out the curved surface area of cylinder. That is very easy. And then third, you find out the curved surface area of hemisphere. All the formulas you know. I am not going to tell you the formulas again. Refer your notes. Okay? And the formulas must be by heart to you. Just do one thing. Write down all the formulas on the paper and stick that paper on your cupboard or on your fridge or your wall, wherever you can read them time to time. So you don't have to by heart them. Just while going from here to here, just refer 1 or 2 formulas, by heart the formulas or revise the formulas so that you will remember the formulas thoroughly. The third problem is a test tube has a diameter 20 mm and height 15 centimeter. It's a test tube. That means it's a cylinder and hemisphere on the bottom. So this is your test tube. This is your test tube. Diameter is 20 mm. So the radius is 10 mm. And a height 15 centimeter. Now height of test tube is taken from this end to this end. 15 centimeter, that is 150 mm. Radius is 10 mm. Now if this is 10 mm, this is also radius. So this is 10 and this is 140. So the cylinder height is 140, radius is 10, and for the hemisphere radius is 10. Let us say what they say further. The lower portion is hemispherical and the upper portion is cylindrical. Find the capacity of test tube. This question was appeared in March 15 exam for 4 marks. Very simple question for 4 marks. Only you should able to interpret the dimensions of the figure. You should able to bifurcate this figure into 2 parts, that is lower part is hemisphere, upper part is cylindrical, and you should able to find out. Now they want to know the capacity. What will be the capacity? The capacity will be the joint capacity of this cylinder and this hemisphere. That means you have to add the volumes of the both figures. So total volume will be the volume of cylinder plus volume of hemisphere. Correct? So volume of cylinder is pi r square h, and the volume of hemisphere is 2 by 3 pi r cube. Correct? So please pause your video here, substitute this figure into the formula of volume of cylinder and volume of hemisphere and find out the final answer. Please pause your video. The answer is 46.05 centimeter cube. In your case the answer may be in the mm cube. Some figures are same, answer is, the decimal point is at a different place, because I converted this 15 centimeter into mm. What you can else do, 10 mm you have, so you can take 1 centimeter and 15 centimeter. So that much decimal point difference will be there. You can keep that in the mm cube or you can keep in centimeter cube, doesn't matter, but unit must be there. Okay, let us see example number 4. This is interesting example. This example or similar example appeared in July 15 paper for 5 marks. Example is extremely simple. Okay, just the length of the example is more. What they say, an ink container of cylindrical shape. Now let us draw first the ink container of cylindrical shape. This is ink container. Cylindrical shape is filled with the ink up to 91%. 91% ink is filled. Okay. Ball pen refill of a length 12 centimeter and inner diameter 2 mm. Then the refill is there. This is the pen refill of length 12 centimeter. Length 12 centimeter and diameter, inner diameter is 2 mm, that is the radius is 1 mm, or I can say 0.1 centimeter radius. Okay, are filled up to 84% only. Now this refill is not fully filled, it is filled into 84% only. Okay, if the height and radius of the ink container are 14 and 6 centimeters, height is 14 and radius is 6 centimeters. Since every other things are in centimeters, I have taken this radius also, radius of refill, though it is very small, I have taken it into centimeters only. They ask, find the number of refills that can be filled with this ink. Very simple. Now volume of the ink, if the ink is fully filled up to top, this volume of the ink, if you divide by the volume of the refill, if this refill is fully filled, you will get the number of fully filled refill you will get. Okay, by dividing volume, this volume by this volume. But they are not fully filled. So I can say the volume of ink is equal to pi r, ri I'll say, pi r square h. Correct? H is, I'll say that, ink container. But is this fully filled? No. This is 91% filled, means you have to multiply by 91 by 100. Now you have to divide this by the volume of how much ink you are filling in the refill. Same, pi R, I'll say refill R square H R, but this is only 84% is filled, and this combination will give you number of refills. The N will give you the number of refills. Now before going further, we can just say that this 100 will get cancelled, pi will get cancelled, and you have R of the ink, that is a 6 square into 14 divided by 0.1 square into 12 into 91 into 84. Now please pause your video and solve this. Very simple example. Just find how many refills will be there by these calculations. Do it now please. The answer is 4550 refills. You have to write your answer in the one line. 4550 refills will be filled. This is your final answer. Write the answer separately there, okay, and highlight the answer. We'll go to the last example of 6.8. The fifth example is also interesting one. You have to interpret the figure perfectly, okay, otherwise the example is very simple. In the fifth example, they say that a cylinder of radius 12 centimeter, there is a cylinder of radius 12 centimeter, R is equal to 12, okay, contains water up to the height of 20 centimeters. Up to the 20 centimeter water is there. Okay. A spherical iron ball is dropped into the cylinder. If I drop a spherical iron ball into this, what will happen? The level of the water will raise, correct? A spherical iron ball is dropped into the cylinder and thus the water level raised by 6.75 centimeters. Now this water level is raised by 6.75 centimeters. What is the radius of the ball? What is the radius of the ball? Very simple example. Now remember, in this case, always not necessary that whatever is given has to be used in solving that particular sum. Now in this case, this 20 is useless for us. This height 20 given is useless for us. Why? First of all, what is to be find out? The radius of this ball. Okay. How you will find out? By the volume. If you can find out the volume of this spherical ball, then you can easily find out the radius of this ball. Correct? Now what is the volume of this ball? If the water level is here, after dropping the ball, the water level is raised, then the whatever the raised water level is the volume of that ball, and that volume is equal to radius of the cylinder and this water level increase. That is the volume of the ball. So volume of the ball is equal to pi r square h. The volume of the ball is equivalent to the whatever this water level is increased. Volume of water level increased. And what is the volume of water level increased? This is the cylindrical shape. So pi r square h. And what is r here? The r of the cylinder. So pi into 12 square into 6.75. Because we have to do nothing with this 20. This 20 is useless information for us. We are only interested in how much water level is increased. Okay. If they have stated that the total height of the cylinder is something 25 and only 20 centimeter water is there, and after dropping the ball it comes up to the top edge of the cylinder, then this is required. Top edge is 25, this is 20, so the raised height is 5 centimeters. But now in this case they are straight away given that the water level is raised by 6.75 centimeters. Correct? So our volume of the ball is this. And when you know this, but what is the formula for the volume of the ball? This is the volume, calculated volume. But you have to equate this with 4 by 3 pi r cube. So if you solve this expression, you will automatically get the radius of the ball. It is easier to solve because this will, pi will go. Don't unnecessarily calculate all these things. It will go somehow. Okay? So please pause your video and find a radius of the ball. Please do it now. The answer is radius of this ball is 9 centimeters. Please check your answer. I hope you are successfully able to solve this just multiplication and division. Okay? And after that you have to take the cube root of other side to find out the value of r. So answer is 9 centimeter. So friends, here we are finishing exercise 6.8, and along with that we are also finished the chapter number 6, mensuration. Now we will go to the problem set of this chapter. That means the combination of all the examples, all the exercises in one problem set. Thank you very much.